Right, so tips, obviously, like I said, regular pencil or a pen. I would prefer a pencil, just in case you mess up, then you can you don't have to start over. Colored pencils will be working best for adding color, so please do not use markers. Crayons are okay, but you're just going to have to color very lightly so that you could still see the writing underneath them. Focus on the main ideas. Don't stress if you don't get everything colored right away. Adding more color and detail later will help you study. So I would worry about filling in the words first and then coloring later. All right, listen for doodle tips that'll help you make your notes easier to remember and study. Doodle notes take some work, but you'll notice they do really help you learn. So it keeps your hands busy and it kind of gives you some creativity to add to your notes. I do want you to be aware that a lot of this info is really in depth, and you're going to find that while I want you to kind of get the general gist of what we're looking for with acids and bases, some of the real chemistry, like I'm not going to really hold you accountable for, but I want you to have the opportunity to understand it. Okay, so let's go ahead and get started. So the pH of a solution is a measure of the concentration of hydrogen ions in the solution. So I know it's been a while since we've talked about ions, I guess probably last week, but remember, an ion is any element that has given or taken in electrons. So for an acid, that means that it's given away. It's a hydrogen ion, so it's an element of hydrogen. And for it to be an acid, that means that it's actually given away its extra electron, making it an H positive. So that's a positive ion. All right, so think about this. Chlorine is used to sanitize pools and keep them safe for swimming. I put chlorine in my swimming pool. It works best to disinfect a pool only when the pool water has a correct pH. So what do you think? Do you think pools need a high pH, meaning it would be a base, or a low pH, which would mean it would be an acid, or neutral to be suitable for swimming? So I kind of want you to be thinking about what your thoughts are on that. All right, so here's where we're going to start on the doodle notes, the top left-hand corner of the side that has the ruler in the middle that goes from 0 to 14. It looks like a ruler. So this is where we're going to start. All right, so acids are substances that break apart in water to form a hydrogen ion. So it's an H positive, a positive ion, meaning it will lose the electron. So that will give it an overall positive charge. All right, so acids have a pH less than 7. Substances further away from 7 on the scale are considered stronger acids. So less than 7, a 6, a 5, a 4, a 3, a 2, a 1. So obviously a 1 is a much stronger acid than, say, a 6. So just to keep that in mind. Acids will also react with metal and carbonates. So make sure you filled in the red words on your notes. They release hydrogen ions. So hydrogen ions are created when hydrogen loses an electron, so it has a positive charge. So when that reacts with water, it will actually lose its electron. Some properties: they are sour to taste, but do not test them by tasting. So I want you to think of like lemon juice, very sour tasting, so that's very acidic. React with bases to form water and a salt. So we'll talk more about this after you learn about what a base is, and that's next. All right, so here's the scale. This is on the left side of the scale that you have on your paper, and you can write in the examples for each one. All right, so you can see at a 6, we have milk. A 5, you could write in banana. A 4 is a tomato. 3, cola. A 2, lemon juice. A 1, sulfuric acid. And a 0, stomach acid. So you could see as you go from 6 down to 0, you're actually increasing in strength. So Acids that are stronger are further away from 7. 7 is considered neutral. Pure water, H2O, pure water, is considered a 7. Let's see. A pH change of 1 is a 10-fold change in strength. So if you go from a 6 to a 5 is 10 times weaker in strength. So a pH of 4 is 10 times more acidic than a pH of 5. So I'm sorry, I went the opposite way. So the 4 is 10 times stronger than a 5. A 5 is 10 times stronger than a 6. So it's by 10-fold. Okay, everyday acid examples. We have tea, vinegar, and citrus fruit. So there's some examples for you. So everyday examples that you can write in. Okay, so check your work. Make sure that you have all of that written in. Do you have all the key information that is written in red? How do you visualize adding color to emphasize the most important parts? So I am going to suggest that you don't add don't cover up your words or make it so dark in your coloring that you can't read your words. So I would color very lightly over the areas that have words. What facts seem to be easy to remember? What seems more challenging? So kind of think on that part. Okay, so now we're going to move on to the right side of this paper where we talk about bases. Alright, a base is a substance that breaks apart in water to form a hydroxide ion. So you have OH negative. So on that hydrogen, this one has actually gained an electron. So it's got an overall negative charge. So these guys have a pH that range from 8 on that scale all the way up to 14. So anything greater than a 7 is considered a base. They release hydroxide ions, which are negatively charged ions made of one hydrogen bonded to one oxygen. So that's the other part of water. So remember, H2O, there's 2 hydrogens. Here's the negative one for the base. If you combine it with an acid, which is an H positive, you're going to have pure water. So kind of keep that in mind. Okay, so bases feel slippery, so think of like soap. They are bitter tasting, but do not test it by tasting. So hopefully you've never had to taste soap, but if you ever said anything foul or said a bad word, maybe I know I did this to my son, stuck a bar of soap in his mouth because I said you gotta wash your mouth out with soap if you said a bad word. So it's bitter tasting. And they do react with acids to form water and a salt. And you'll see kind of how that happens here in a little while. Okay, so on the pH scale, bases are 8 to 14. A pH change of 1 equals a 10-fold change in the ions. A pH of 9 is 10 times more basic than a pH of 8. So you can kind of see, make sure you fill in the examples on your scale on your paper. An 8 is toothpaste, a 9 is baking soda, 10 milk of magnesia, that's something you take if you have a stomach ache, 11 ammonia, that's what we use as a cleaner, it's in Windex, 12 soapy water, 13 bleach, and 14 drain cleaner. So very, very strong base. So the further away from 7 you get on that scale, the stronger of a base it is. All right, everyday base examples. Baking soda is a base, bleach is a base, and soap. All right, check your work. Make sure you've got everything filled in. Do you have all the key information in red filled in? Make sure that where you're adding color that you're not taking away from the words that you need to read. And think about what things are easy to remember, what parts are more challenging. Okay, so this is on the other side of the page. So we're going to talk about neutral substances. So neutral, oh, I'm sorry, it's at the bottom. Okay, so neutral substances have a pH of 7 and are not acidic or basic. So you need to be aware that water is a 7. Okay, equal number of hydrogen negatives and hydrogen positives are present. All right, add color here with intention. So that was all based on the first side. I apologize for that. So add color with intention, group concepts into similar color groups. Acids, maybe make those all in red. Bases, maybe you want to color in blue, like you can see on the right side of this document. Color lightly so that you don't cover any of the words or the details. All right, so now we're on the back of the paper. More details about the pH scale. All right, so on the other side, pH stands for potential of hydrogen. pH, potential of hydrogen. 1 through 6 are acids and 8 through 14 are bases. 7 is 7 is neutral. Further away from 7 is a stronger acid or a base. Technically speaking, pH is a measurement of the acidity of the acidity or alkalinity of an aqueous or water-based liquid compound. All right, so remember, if something is an acid, it's less than 7. If it's alkaline, that means it's more than 7. All right, so bases are substances that break apart in water to form a hydroxide ion, the OH negative. The greater the concentration of OH negative ions, the stronger the base. So for example, sodium hydroxide is a corrosive base used in soap, paper, and textile industries. So when it's, we also call that an alkali. So it's alkaline, it's a base. All right, acids are substances that break apart in water to form a hydrogen ion, an H positive. The strength of an acid is based on the concentration of hydrogen positive ions in the solution. The more hydrogen positive, the stronger the acid. All right, let's talk about reactions here. So this is where we get into a little bit of complicated chemistry that you will see again in 9th grade, but it's worth mentioning. So an acid mixed with a base produces a salt and water. This is called neutralization. All right, so if you mix the two together, you will get not just water, but also a salt. So if you see that in the diagram at the very bottom, you'll see that hydrochloric acid mixed with sodium hydroxide. So hydrochloric acid is hydrogen and chlorine bonded together. Sodium hydroxide is sodium, oxygen, and hydrogen bonded together. If you mix those two compounds together, you will get sodium chloride, which remember is table salt, and H2O, which is water. So you can see on the right side there, that's how it will, when they all come together, that's what you'll be left with. Okay, all right, so an acid and a carbonate, a salt, you will get a salt and a carbon dioxide. So acids react with a carbonate to give off carbon dioxide. This gives cookies and cakes their fluffy consistency. So, you know that they have to rise. So when you bake cookies and you bake cakes, they will rise. So it's because that carbon dioxide is being created to give it some fluff. Okay, so what is an indicator? So next topic. An indicator, we're going to use these probably later in our lesson. An indicator is a compound that changes color when in contact with either an acid or a base. Litmus paper is an indicator that turns red in an acid and then blue in a base. A universal indicator is a mix of indicators that changes a variety of colors to show how strong or weak an acid or base is. So while litmus paper will just turn red or blue, it's either acid or base, the universal indicators have a variety of different colors, so it'll show you the strength of it. Okay, check your work. Make sure you have everything filled in up until this point. All right, so remember to add color with intention. So if you want to model it after this image, groups concepts into similar groups, acids being red, bases being blue. Use a pH scale picture to color accurately. So if you can use, acids typically in litmus paper will turn red and bases will turn blue. So it's a good visual to keep on your notes. Okay, all right, and then you can still think about this now that you know a little bit more about acids and bases. What do you think the pH of pool water needs to be in order for chlorine to do its job? All right, so pick a number from 0 to 14 and explain your reasoning. So think about it and write it on your paper, and I'll let you know if you're right.